Well, hello everyone and welcome back to our class of foundation engineering. We try to continue the class with the chapter number 4, the ultimate bearing capacity of shallow foundation, very specific cases. Today, we are going to talk about the point number 3 of this chapter, which is about the foundation on layered clay. So sometimes we have soft clay and stiff clay, or inversely. So in that case, if the bottom layer is not that far from the surface, that bottom layer will influence the bearing capacity, and the effect of that bottom layer cannot be ignored. Okay, so in that case, we have some equations that help us to take account the effect of the bottom layer on the bearing capacity. So this is what we are going to talk about today. Okay, so foundation engineering, foundation on layered clay. Before we start, I would like to remind you this equation, this formula, we have been, I think, talking about using so far. And this is the general equation of bearing capacity of shallow foundation, including all the factors: shape factor, depth factor, inclination factor, okay? So in the previous video, I think I said many times that this equation apply only when we have uniform ground, when the soil is uniform, or at least it's uniform up to very considerable depths of the soil. Okay, so this reference derived an equation for the bearing capacity of foundation on layered clay soil based on this failure. So this figure is showing, illustrating at least two soil layers. You can see the top layer and the bottom layer here. Okay, this line is showing the limit, the boundary between the first layer and the second layer. Okay, so, and this is just failure. You can read here, cylindrical failure surface. So the failure surface is here. It means when you are loading, after loading the soil, the foundation, this is how the failure will happen in the ground. Okay, so one thing very important is, you can see here CU1, CU2. Of course, phi is 0 because we are talking about clay, okay? So no internal friction angle. So no friction angle. So the undrained shear strength of the top layer, the upper layer, and the bottom layer are different, okay? So this is what I was saying. If you have some cases, this upper soil layer is softer than the bottom one. It means the bottom one is stiff. Or sometimes inversely, you have the upper soil layer is stronger than the bottom one. Okay, so depending on the ratio between these two, the underside strength of the top layer and the bottom layer, they propose equation to estimate the bearing capacity. Okay, H, as you can see, is the thickness of the top layer of the upper soil layer. Okay, DF, I think you know already what that means, and key you know. Okay, B is the width of the foundation. So for undrained condition, okay, as I said, phi is 0. Where we have Cu, the undrained shear strength of the upper layer, and this is Cu1. Cu2 is the undrained shear strength of the bottom layer. Okay, these two undrained shear strength are, okay, shear strength for the upper and the lower clay layer. respectively. The ultimate bearing capacity of this foundation can be expressed as this equation. Why is it that shorter than the general one? Do you remember that general one, as I said, is when you have everything uniform soil, and when phi is 0, the if you are dealing with clay, you don't need all these parameters. Okay, we will focus only on this one, this term, including C. Similarly, if you are dealing with clay, for example, maybe with sand, it will simplify also the equation. I think you should know that by now. So this should be 0, and these are just 1. Okay, so that brings us to consider only this Q, which is just the short charge. So what is important here is this one and this. Okay, this one we have it already here. It is the underlying shear strength of the upper layer, right? This one, Cu1, and NCFCS and FCD. This the NC, I think you know already the name. It's the bearing capacity factor. Okay, FCS is for the shape factor. FCD is depth factor. We don't need FCD here because we are FCI here is for inclination. We are supposing that the load is vertical, not inclined. In case the load is inclined, then you have to consider this